Hey guys, we're going to look at ions today, and more importantly we're going to start looking at how those ions can go on to form those ionic formulas. So one thing I always tell students is that they should always learn to remember things, and especially when it comes to common ions to learn. And so we've got around about 7 or so ions, key ions that I would like all students to learn. You've got the OH-, which is the hydroxide ion, SO42- sulfate ion, PO4 3- phosphate ion, NO3- nitrate ion, CO3 carbonate ion, NH4+ ammonium ion, and HCO3- hydrogen carbonate ion. These ions are very important and we should learn them. So get a post-it around your house with these ions on in your room so you remember them, because they're going to be really valuable for you when you come to finding out ionic formulas. So after learning these ions, I want to draw your attention back to the periodic table. And this can also be used to help you learn some ions, or in fact deduce ions, so you don't have to learn them. Just remember the fact that, okay, I've got elements in group 1, lithium, sodium, potassium and so on. All of those are going to be +1 ions. All those in group 2, like beryllium, magnesium, calcium and so on, are going to be +2 ions. You miss out the middle block, then you've got boron, aluminium, all those are +3. You can leave group 4 out. All those in group 5, because they've got 5 electrons in the outer shell, they only need 3 more electrons, so they're all -3. Those in group 6, okay, they've all got 6 electrons in the outer shell, so only need 2, so they become -2. And all those in group 7, the fluorine, chlorine, bromine, they become -1 charged ions. And always remember this, the negatively charged ions, okay, here, they end in "ide". So for example, where you've got, say, fluorine, chlorine and bromine, when they become ions, when they become minus charged ions like Br-, okay, that is referred to as bromide. Okay, it's a bromide ion. Okay, so you can have, say, if you've got oxygen, okay, and oxygen as the ion is O2-, so we call that oxide. So these are the ways you actually name the negatively charged ions. So again, the periodic table here becomes valuable as it helps you remember what those single elements, when they become ions, okay, how we can remember by looking at the group number what charges those ions are going to be. There is one exception I do want you to remember, okay, and that is silver. Now silver is Ag+ ion, yeah, okay, so silver has what we call a +1 charge and it's Ag+. Hydrogen, you remember hydrogen as a hydrogen ion is a H+ ion, okay. Later on, you'll notice that hydrogen also has a H- ion, especially when it's reacted with metals, and we call that a hydride ion. And look, hydride ends in "ide" because it's a negatively charged ion. So here's your periodic table becoming very important here that we know how to use it. Okay, let's look at some examples. Very, very important, you need to know how to actually deduce the formulas of these ions. So, if we say, for example, give you a substance name, which, okay, that's sodium chloride, you'll all know, remember that sodium's in group 1, so that's Na+, chloride is in group 7, that's Cl-, so we know the formula there is NaCl, or sodium chloride. We should be happy with that, because you need, for every 1 + 1 charged sodium, you need 1 negatively charged chloride ion. If I was to look at, say, magnesium, bromide, and I hope you can see this now. Magnesium will always be Mg2+, which is the ion. Bromide is Br- because it's in group 7, so it's a -1 charge. But what you've got to think about here is, how many of these bromide ions do I need to balance that 2+ charge? I need another Br-. So I've got now overall a -2 charge. So the formula there is going to be Mg, because we only need one of them, Br2. Okay, so that's what we've got there. Let's go on to something else. Let's go on to say, let's go for calcium oxide. So calcium is just single elements, nothing else is combined in there. Okay, so calcium oxide, we've only got 2 elements we're going to look for. So calcium, the ion of calcium is Ca2+, oxide is O2-, it's in group 6, calcium's in group 2, so it's 2+. And here we go, the formula there is, you only need 1 2+ charge of calcium and 1 2- charge of oxygen, so that becomes CaO, right? Okay, let's go for something like aluminium fluoride. So aluminium, here's the name, aluminium fluoride. So how can I make that into an ionic formula? Aluminium's in group 3, so it's Al3+. Fluoride is in group 7, so that's F-. But how many of the F- do I need to balance that 3+ charge? I need to have 1, 2, 3. So now I've got -3 there. So now what we've got then is, it's for every 1 aluminium, we need 3 of the fluorides, so it's AlF3. There you go. So they are some simple ones. Now we're going to move on to some complicated ones. Now if I started looking at, say for example, let's go for sodium sulfate. So sodium sulfate. Now sodium, you know, is in group 1, so that's Na+. Sulfate, you need to remember that ion. On the very first 7 or so ions I gave you to remember them, sulfate is SO4 2-. Now, in this scenario, what you're going to look at here is this. For every 2- of the sulfate, we've only got 1 sodium. So we've only got 1 Na+, so I need 2 of these Na+. Yeah, so that's now overall +2 to balance that 2- charge. So the formula there is going to be Na2SO4. Okay, that's your formula there. Let's go for something else. Let's go for something now, like say, let's go for ammonium oxide. So if I go ammonium oxide. Okay, you all know ammonium is one you've got to remember is NH4+, oxide is O2-. So we need to think, we've got a 2- charge here and a plus charge here, so I need another NH4+, another ammonium ion to give me overall +2 to balance that 2-. So it's NH4, and what we need to do here is this: whenever we've got more than one atom, okay, more than one atom or more than one element in the ion, like here we've got more than one element in the ion, we've got nitrogen and hydrogen, we need 2 lots of those. So what we do there is we put a bracket, 2 lots of ammonium for every 1 oxygen. So that's the formula there. Let's go for something else whereby we would use brackets. So here we go, let's go for aluminium hydroxide. So if we look at aluminium hydroxide, aluminium is Al3+, hydroxide is OH-. So how many OH- do we need? Each one's -1, so I need to have 2 more there. So I've got a -3, which will balance the +3. So the formula there is going to be Al brackets OH with a 3, because I need 3 lots of the OH. Always put brackets around the whole of the ion there, because there's more than one atom or more than one element there. Okay, so these were simple ways of doing your ions and working out ionic formula. Very important that you do learn these key ions here. You must learn those key ions there, because that will help you go forward.